All right, so now we're going to go ahead and look at 1.6 here. 1.6 is these compound inequalities. And we'll have to talk first about the and the or and what they mean. So we're first going to look at some definitions here. So we're now in 1.6, we're going to talk about and what it means. Okay, and means it has to be in both, has to overlap. And so and means it has to be in both and it must overlap. It's also called an intersection. So an and is going to be called an intersection. And sometimes we represent the and with an upside down U. So and means it has to both happen. And it's also called an intersection because it's where they overlap. And we'll look at some pictures here in a moment. Or, on the other hand, is either one. And it's also called a union. And we represent an or with a right side up U. And if we think about a union is like a marriage. When people get married, what happens to their belongings? Well, they all get combined together. So everything goes together. So when you think of or, it's going to be either one. It can be an either one, and they're going to be united together. So an or is always a larger one. And is always smaller. And is where they overlap. Or is basically everything put together. So now we're going to graph a few of these, just to make sure we understand the difference between an and an or. So let's graph this one. How about x is greater than or equal to 5, and x is, how about less than 12? So we're going to go ahead and graph these. Now the important part is this is an and. And an and is also called an intersection. So sometimes they'll want you to label it as an intersection. And we put both of these together on the same number line. And then we can compare them. And we can see where they overlap. So the first one I'm going to look at is x is greater than or equal to 5. Now it points to the right. And so we're going to use a square bracket because it's got the bar underneath. And then we're going to shade this out to the right. The other one says x is less than 12. So it's pointing to the left. So we're going to have to shade to the left here. Now, when we talk about the and is the intersection. And that means we're looking for where these overlap. And where do they overlap at? Well, we've got a blue line and a green line. It looks like they overlap right here, don't they? Right in the middle. This is where they overlap. And we want the overlap part. So then what would our answer be in interval notation? Well, our answer in interval notation would be 5 with square brackets to 12 with parentheses. work through some more examples first, just so we understand these before we start solving. We have to know how they work before we actually start manipulating around the inequalities. So let's try and solve and graph another one. How about x is less than 9 and x is less than or equal to 3. So let's see how this one would work. This is another example that you may encounter. First one, we'll graph it in blue. So x is less than 9. Here's my 9. It's pointing to the left. So we'll shade back to the left. The other one is x is less than or equal to 3. So 3 is going to be over here somewhere. And it is also pointing back to the left. And we're going to use the square bracket. Now we want where they overlap, because remember, what is and? And is an intersection. So where are they going to overlap at? Well, where they overlap at is right here on the end, isn't it? Remember, this is negative infinity. So what would our answer look like then in terms of interval notation? We only want where they overlap. And so where do they overlap from? Make sure it goes in the correct order. Negative infinity, comma 3 with a square bracket. Is everyone okay with that? We just need to make sure we know the difference between an and an or and talk about all the different cases that we may have happen. So those two we got an answer. Let's look at one now that has no solution. So let's try and graph this one. Let's try and graph x is greater than 10 and x is less than 4. So x is greater than 10 and x is less than 4. And this is an intersection. Now, if we think about this with common sense, is there any number that's bigger than 10 and also smaller than 4 at the same time? Can we have a number that's bigger than 10 and smaller than 4? No, that can't ever happen, can it? Because there's no number bigger than 10 that's also smaller than 4. So we know this should have no solution. So let's try and figure out why it would have no solution. And the first one says x is bigger than 10. So we find our 10. It's pointing to the right, so we shade out to the right here, and we use parentheses. What about the other one? The other one is x is less than 4, and it's going out to the left because it points to the left, and we have no solution. They never overlap. So this has no solution. Okay, so they never overlap, therefore they have no solution. Okay. Now let's talk about or. Or is different. What does or mean? Or means we're going to basically put them together. So when we work with these with the or, we're going to have to splice the pieces together. So let's try to graph x is greater than or equal to 5, or x is less than negative 2. And an or, by the way, is a union. And so the or means we're going to put them together. So we're going to be splicing these together. So we've got x is greater than or equal to 5. So we've got our 5. And it's pointing to the right, so we'll go ahead and shade to the right over here. And we need a square bracket. What about the other one? X is less than or negative 2. So it needs parentheses, and it's going to be shaded back to the left. The one we did a moment ago was an and the and had no solution, right? Because they never overlap. What does or mean, though? Or means we combine them together. So how we write our answer when we combine them together is like this. This is negative infinity. This is positive infinity. So we write them like this. We use parentheses negative infinity, comma, negative 2 with parentheses. Then we use a U for union, because U means we're putting them together. We're splicing the pieces together. And what's our other half? Square bracket 5. And where does it go to? Positive infinity. So when you have a union or an or, that means we're putting the pieces together. And that's how we write it. The U is kind of like a plus, but we can't use pluses in sets, so we have to use that U. But it's basically saying this piece plus this piece. Another possible outcome from one of these with an or is an infinite number of solutions. So let's try and graph this one. Let's say x is greater than 3, or x is less than 10. Okay, so the number needs to be, wait, I get these mixed up. Let's make sure we've got it right here. Okay, we've got x needs to be, greater than 3 or less than 10. Yep, so it's going to work the way we want it to work here, I believe. So let's look at our first one. X needs to be greater than 3. So we've got our 3 here. It's pointing to the right, so we're going to have to shade to the right. And we use our parentheses. What about the other one? Well, the other one is x is less than 10. So here's our 10. It's pointing to the left, so we have to shade to the left. Now, what does that or mean? Or means we combine them together. And that or is also called the union. And if I put these together, what does it do? If I put these pieces together, it covers the entire line. So this covers the entire line. When we add them together, the blue piece plus the green piece, when we put them together, it covers the entire line. So in that case, your solution would be negative to positive infinity, because that covers the entire number line. And if we think about it, numbers that are bigger than 3 and smaller than 10, well, that's a lot of 4. So you can have things like 5. 5 is bigger than 3, smaller than 10. You can have 12, because 12, right, is bigger than 10. Doesn't have to be both of them, just one of them. Or means union, so we put them together. So we have an infinite number of answers, so we use negative to positive infinity. When we go to solve these, we're going to be solving each one separate from the other one, and then we're going to be graphing them. So that's what we're going to be doing. We're going to have to solve each one. We're going to have to see if it's an and or if it's an or. and then we'll put them together on the number line and write up our answer. So I'm going to pick a couple of these from our textbook to look at. And then we'll look at the one application that I gave you. So let's make sure we can work through these here. I'm going to pick some from our textbook. I'll give you examples of all the different types that we need to make sure we can cover. Let's look at, how about question 45? And this is on page 122. Number 45. So 122, question 45, this is an or. We'll do some ands and we'll do some ors. I want to mix them up because that's how your homework is done. They're all mixed up. So we'll do this or first. So we've got 4x plus 1 is greater than or equal to negative 7, or a minus 2x plus 3 is greater than or equal to 5. So what we need to do is just split it down the middle. We're going to work out each one separately from the other one, and then we're going to put the pieces together. So let's go ahead and work this one out. I'm going to do the left one first, so I'm going to subtract that 1 off. And that gives you then 4x is greater than or equal to a negative 8. Divide by your 4. Do we switch our inequality symbol? Yes or no? No. Why not? We're dividing by a positive 4. When do we switch it? When we divide by a negative. So it stays the same. And that gives you then x is greater than or equal to a negative 2. What about the other side? Well, we're going to subtract our 3 off. And that gives you negative 2x is greater than or equal to, it looks like a positive 2. Divide by your negative 2. Now, what happens when we divide by a negative now? That sign gets flipped around. So we'll flip that inequality symbol. Positive over negative makes it stay negative. So we work these out. We put them together on the number line. We've got x is greater than or equal to a negative 2. So we've got our negative 2. It points to the right, so we shade to the right with a square bracket. Just like that. What about the other one? Well, we have a negative 1. Remember, negative 1 is going to be in front, right here. And it's pointing back to the left. And we've got that. Now, or. Or is a union. And so what does it mean if it's a union? Union, that means we combine. So if I combine all these together, then what does it cover? It covers the entire line again. So your solution would be negative to positive infinity. No, because remember, on infinity, what do we always use? No matter what, infinity gets parentheses. Okay, so we have brackets here, but when we cover this entire line, see what it's doing is it's covering all of that, right? Because it covers the entire part, and that's negative to positive infinity, and negative to positive infinity, they always get parentheses. So make sure you note that. Okay, let's try a different one. How about 40? Well, let's go do an and. I'll kind of mix them up a bit here. How about we do 26? This is an and. So it's x plus 5 is less than or equal to 11. And x minus 3 is greater than or equal to a negative 1. And again, I'm kind of mixing up the ands and the ors. I don't want to put them all together because your homework is all mixed up. Your tests will be mixed up. So you need to make sure you know the difference. We have this and. We're going to separate. I'm going to move that 5 over on the left. And that makes it then x is now less than or equal to 11 minus 5. That makes this 6 then. Other side, we're going to add that 3 over. So that makes it then x is greater than or equal to, it looks like 2. Now, what do we know about an and? And is an intersection. So that and is going to mean that intersection there. And when we talk about intersections, what are we looking at? Where they overlap. So we're looking for the overlap. Go ahead and graph these out now. We've got x is less than 6. So I'm going to go ahead and put the 6 over here. Less than or equal to, so we use a square bracket. It's going back in that direction. What about the other one? X is bigger than 2, bigger than or equal to 2. So we've got our 2. It's pointing to the left, so we go ahead and move out to the left. Now, what do we know? We have an and, so what does the and mean? And means we look for the overlap in both. So there's our overlap. And so that would then be with the overlap, square bracket 2 to 6, also with a square bracket. I want to do one more of these before we look at an application. And then we should have enough time to just barely start 1/7. So let's look at one more of these. How about question 62? Well, let's see. I want to do one. Well, let's do another or one. Let's do question 60. So for question 60, we've got a negative 8x is less than or equal to a negative 24, or a minus 5x is greater than or equal to 15. Splitting it up, or means union. So it says give the solution set in interval notation. So it's to solve each compound inequality, graph the solution, and write it in interval notation. So first thing we do is divide by that negative 8 on the left. Now, when we divide by a negative, that means my inequality symbol does what? Yep, that switches around. Negative and negative makes it positive, and 24 divided by 8, well, that looks like that's going to be a 3 there. Same thing on the other one. Divide by your negative 5. That's going to switch that then around again. So this piece will switch. So your inequality symbol will go the other direction. There's our x there. Positive divided by negative makes it a negative 3. And now they go to the number line. This is a union. And we've got a negative 3 and a positive 3. Make sure they're in the correct order. Our first one is a positive 3. It's pointing to the right, so we shade to the right with square brackets, just like this. The other one is a negative 3, and it's pointing to the left, so we put a square bracket, and that's going back to the left. Now the or means we combine them together, or is a union. So we're going to combine. And how do we combine them together? Well, they're going to be put together with a U. So remember, this is negative infinity. This is positive infinity. So we've got negative infinity, comma, negative 3 with the square bracket. We use that U for union. And we're going to unite that with 3 to positive infinity there. So this would be your final finished answer. So you're basically putting the pieces together with a U for union. Now we're going to look at our homework, and I want to talk about the last question. I want to talk about question 10. I think question 10 is a good question. It makes you think about how much material that you need. So I'm not going to work it out completely, but I'm going to do the first decorator for you. So this is your homework. 1.6. I'm going to look at question 10. I am not going to work it out completely. I am only going to do Jane, the first decorator. So what we're trying to do is figure out how much material we need to buy. So let's read the directions, because it's very important that we read the directions on this. Each of 6 decorators has to paint a room. So we're only going to paint the walls. And then put a wallpaper border around the room at the ceiling. Now, 1 gallon of paint covers 400 square feet, and 1 roll of border contains 5 yards. Each decorator has 1 gallon of paint and 3 rolls of border. Here are the decorators with their rooms. We want to give the names of the decorators who either have enough paint or enough border or both. I think we cut off the both there. Or both. So let's look at Jane. Now, I'm only going to do Jane. You'll use the same process to figure out the rest of the decorators. Now, what does it mean if they work? Well, it means either they have enough paint, they have enough border, or both. So if they can do either one, then they're good. So let's look at Jane. Okay, now Jane's room is a 9 by 12. But let's talk about what we have first. Well, first we have 1 gallon of paint. And that 1 gallon of paint, well, that covers 400 square feet. Right? Okay, so we know we have 1 gallon of paint, 400 square feet. Now, what about the border? Well, for the border, we have 3 rolls of border. At 5 yards each. Yep, 5 yards each. So that's 3 times that 5. So that gives me 15 yards. Now, we don't work with yards normally, so we're going to convert this to feet. So then we'll take that 15 times that 3. 3 feet are in a yard. And that gives us then 45 feet. Okay, so that's what we've got. And this always stays the same. So this is not going to change from any decorator. So every decorator has enough paint for 400 square feet and 45 feet of wallpaper. It doesn't change. These are the constants here. So these are always going to be the same. Now let's talk about Jane. Okay, so we know we've got to paint this room and we've got a border wallpaper. So let's talk first about the paint. So if we're going to paint this room, we know Jane's room is 9 by 12. And we know that the walls are 8 foot tall. Okay, so 8 foot ceilings here. So if I look at Jane's room as a rectangle, or rectangular solid, I should say, and it's going to look like this. And we've got 9 by 12. And then it's 8 feet tall. Now we're going to try and paint this room. Okay, so how do we paint the room? Well, first off, we're not going to paint the ceiling. We're only going to paint the 4 sides. So let's look at each side, figure out how much it is, and then we can add it up. So let's paint the front and the back. Okay, for the front and the back, we've got 9 by 8 foot tall. So that means that this area is length times width, which is 8 times 9, which is then 72. Because we've got to paint this. Remember, how do we paint? We have to use an area. And we need 2 of those. Why do we need 2 of them? We've got to times it by 2 because we need a front and back. So 72 times 2 gives you what, 144? I believe, yep, 144. Now, what about the sides? Okay, the sides are done in a similar manner. We've got a left and a right side, so we're going to have to double whatever we get. So what about the sides? Well, the sides are 8 foot tall, 12 foot long. So that area would then be 8 times 12, which is then 96, and we have to double it. Why do we have to double it? Because we've got 2 sides. And that gives you a 192. Now, each decorator is going to be done the same way. All you do is change the room size. Okay, that's it. So like the next decorator is John, so it would be a 10 by 12. Same concept, you just change that 9 to a 10, work it all the way out. Now, do we have enough paint? Well, let's see if we've got enough. What's my total area that we have to use for the paint? The total paint area, we're going to add these together. Total paint area would be that 144 plus 192. And when we add those together, we then end up with 336 square feet. And that is less than 400. So we can paint this room. Okay, so we know we can paint the room. Now, some of these are not going to be less than 400, and in that case, we couldn't paint the room. So if it goes over, we'd have to buy an extra gallon. So we can paint this room with 1 gallon. We're pretty sure we can do the room with 1 gallon of paint. Now, what about the border? Okay, the border is a little bit different. The border is not an area, it's linear feet. So the border is going to be set up the same way, except instead of painting it, we're just going to put a border on it. So the border is going to go around just like this. So So that's going to be that border. And this room again is 9 by 12. It's 8 foot tall, but we don't even care about the 8 foot. Because when we do a border, it doesn't matter how tall it is. We're not wallpapering the entire wall. All we're doing is that little section up at the top. So we don't need the height. We're going to put it in there, but we don't need to really worry about it. So let's look now at our walls. And we want to use the border paper. So let's do the front and back. Okay, the front and back, this is a 9 foot wide room, 8 foot tall. We want to put the strip across here for the border. So this is 8 feet. So we've got 8 feet of border, 9 feet of border. And we have to double it, right? For each wall. No, so 9 feet for each wall. So that 9 times 2, that gives me then 18 feet of border. So that's what we've got for the front and the back. Now, how do we do the side? Well, the side is going to be done the same way. It's 8 by 12 here. I don't care about the 8 foot tall ceiling. That's not the important part. The important part is the length of it. So it's 12 foot each wall. And we need 2 of them. So 12 times 2 is then 24. So how much total border do we need? Well, my total border that I need, this is feet here, is going to be 18 plus the 24, which is then 42 feet of border. Now, I can border this room because it is less than 45 feet. So, in this case, you would have Jane as one of the answers. So we need to make sure that we don't go over that 45 feet for the border, and also that we don't go over the 400 square feet for the walls. Yeah, I don't think we really have enough time to move on to the next section. I would have liked to have done a little bit out of 1.7, but I just don't think we have enough time. I think we just barely get started with it. So we'll cover 1.7 next time. So what's going to be our homework? Well, our homework you should be able to do now. 1.6 you should be able to do them all. And 1.5 you should be able to do them all. So 1.5 and 1.6 you should be able to complete them all. If you haven't finished 1.4, go watch the videos and finish up 1.4. So that's going to be your homework. Next week, we're going to come in. We're going to do 1.7. Then we'll review for our exam. And if we have time, we'll start Chapter 2. We may or may not have enough time. But our exam is going to be in 2 weeks. So I will see everyone then next week.